Hello, viewers. My name is Andrew Dean. I'm the Vice President of Research and Innovation at Lakehead University. Welcome back to another episode of Research Matters. Now, you may be wondering what the role of research is within a university. Does research really have an impact outside of the labs or the field? How can research make a difference in your lives and our lives? Well, within a university, research provides the foundation for creative thinking, discoveries, and innovations, and facilitates engagement and outreach. Research broadens academic scholarship to strengthen the teaching and learning experience. In each episode of Research Matters, we bring you exceptional researchers from various disciplines at Lakehead University to explore how that research is making an impact within our broader communities. Our researchers are making a difference to better our world, including today's guest, Dr. Michael Rennie. Dr. Rennie is a Canada Research Chair in Freshwater Ecology and Fisheries. He conducts applied research on the Great Lakes and understands whole lake experiments to help improve environmental policies around ecosystem restoration and fisheries management. Welcome, Dr. Rennie.
Thanks, Eddie.
So, as I mentioned, Dr. Rennie is a Canada Research Chair. For those who may not be familiar with this program, this is part of Canada's national strategy to be one of the top countries in research and development. The program helps universities attract and retain some of the world's most accomplished and promising researchers. The Government of Canada invests over $311 million annually to support research professorships in engineering and natural sciences, health sciences, humanities, and the social sciences. Lakehead University currently has 10 Canada Research Chairs as part of our faculty, including Dr. Rennie. Now, Mike, could you maybe tell us a little bit more about your role as a Canada Research Chair?
Sure. Well, I guess the primary role of a research chair at a research intensive institution like Lakehead is to do research. So it allows me the capacity to spend more of the time that I have to be able to dedicate that to research as opposed to, say, service and teaching. It allows me to support the students that I have that are actually doing a lot of the work, graduate students and undergraduates that are doing the research in my lab. And opportunities for collaboration that probably wouldn't be there otherwise, just with some of the, I guess, some of the parts of the award that help facilitate that sort of thing. So both just the name of the award as well as some of the financial incentives that come with it. So yeah.
Great, thanks. So Mike, your research focus areas are abundant with freshwater ecology, food web ecology, fishery science, aquatic ecology, and acoustic technology. Please share your research journey. How did your research interest evolve?
Yeah, that's a good question. So I think I was sold on aquatic ecology, I think, when I took a freshwater field course back when I was an undergraduate student at the University of Calgary out at the Kananaskis field stations. And I can remember, I think the moment was we were in a stream that I probably, the day before wouldn't have thought twice about just, dipping my water bottle in and being like, oh, yeah, perfect mountain stream. And flipping over rocks and collecting benthic invertebrates, so basically larval insects and stuff that live in the stream, and finding this huge abundance and diversity of aquatic insects that I'd never seen before because I hadn't really looked. And that was a pretty monumental moment in terms of sparking my interest in trying to understand like what supports all of that diversity and abundance in these aquatic ecosystems, and trying to understand some of the processes that allow that to happen, or also what are the impacts that we have that prevent that from happening.
We've heard through many of the researchers we've talked to how sometimes, especially at the undergraduate level, something just sparks that research, and it's not always predictable. But then all of a sudden, having it happen and having the facilities and the mentors in place suddenly becomes a career.
Oh yeah, yeah. I don't know that it was ever necessarily on my radar. I was thinking maybe something in ecology and that sort of stuff, but it was that I would say that was sort of the moment that really pushed me on the path that took me to where I am. So yeah.
So, what are some of the research you're currently working on?
Yeah, so most of my research is split into sort of two geographic areas. One is work that I do at the IISD Experimental Lakes area, which is an outdoor research facility with 58 lakes that are set aside for whole lake experimentation. And the other component of my research is mostly focused on the Great Lakes. In the main research I've got going on at ELA right now is focused on ecosystem restoration. So, trying to understand in lakes that have been impacted by things like acid deposition, which was a big problem in the 1960s through to the 1980s, you know, and all sorts of other issues with nutrient additions and other impacts that humans have on freshwater ecosystems. What are some approaches that we can take to restoring those ecosystems? And so we're currently undertaking a whole lake experiment looking at restoration of an acid impacted lake out at ELA. And then the other major kind of component of my research right now that's running on the Great Lakes is trying to look at using new applications of acoustic technology to try and better understand sort of abundance and movement patterns of fishes in the Great Lakes. So we can get into that in a bit more detail later if you want. So I think, yeah.
I was really privileged. I say privileged, having visited the experimental lakes area a few years back, and it was absolutely blown away by the fact that you've got basically this lab that
In the middle of nowhere.
middle of nowhere, and many of our viewers may know of it, but some may not know about it. I mean, this is a really unique place, isn't it, Mike?
Yeah, sure. So it's located between Kenora and Dryden, about 30 kilometers down a gravel road, which you need a road permit issued by the MNR to get to. It's closed after kilometer 4 to the public, but we often have tours and groups that come out to visit the area, so we're not trying to hide anything. It's we're always welcoming new people out there. And yeah, it's been running, I mean, it ran under the federal government from 1969 until 2012, when the conservative government at the time decided they no longer wanted to fund that sort of research. And quite honestly, it's been probably one of the best things that ever happened, because since then we've been a not-for-profit organization under the International Institute for Sustainable Development, have probably, well, I know we have much better funding than we ever did under the federal government, and a much broader mandate for the research that we do. But yeah, no, it's a great place. We've done the royal we, experiments out there over the years that have addressed issues that are pertinent to freshwater protection. So trying to understand the role of nutrients in algal blooms and eutrophication, the impacts of acidification on fish and biological communities in lakes, the impacts of mercury deposition on mercury biomagnification in fishes, to name just a few examples. So
That's fantastic. Okay, we're going to take a short break here, and we'll continue our discussions with Dr. Michael Rennie after the break. Welcome back to Research Matters with Dr. Michael Rennie. Mike, can you tell us a little bit about how you engage students in your research?
yeah, so in our lab, we've got people working with us everywhere from the undergraduate level through to graduate students and the occasional postdoctoral research fellow, as well as several visiting students from other institutions across Canada. I mean, students are the backbone of the lab. They're the ones who are actually out in the field doing the research. I mean, I got into freshwater research because I liked being outside and in boats and doing that sort of stuff. it's now my students that get to do most of that work, and I just come out to help every once in a while. But they're really the ones that are driving the discoveries and the research that we make in the lab. So.
Now, research and students often take financial support. Can you tell us a little bit? Canada Research Chair in Experimental Lakes Area or
Yep.
ISD, but can you tell us a little bit more about funding?
Sure, yeah. So the sort of backbone of my research program and for several researchers that are active in Canada is the Discovery Grants program through NSERC. So that's a really big piece and sort of the bread and butter research funding. I've been lucky enough to receive an early researcher award through the Ontario government, which has been a really good sort of infusion of funding early on to help support a whole bunch of students. Most of that money is earmarked to student support, so that's been a real game changer as well. As well as initially with the Canada Research Chair, also a pot of money from the Canadian Foundation through Innovation. From the John R. Evans Research Fund, which basically funded most of the research equipment that I and my lab uses to actually do the research we're conducting.
That's great. It's great to know the federal government is still there funding research and helping with it.
Yeah. I mean, yeah, it would be certainly a different state of affairs if it wasn't. Yeah.
Research matters. It's sort of our show. Perhaps you could tell us, in your opinion, why this research matters to you, matters to the people in this region, etc.
Yeah. So, I mean, for me and some of my students, like I think some of it is just the esoteric thrill of discovery. I mean, that's a big piece of it, and I think why people get into science and scientific research generally. However, I think from an applied, most of my research is applied. So the questions that I'm trying to answer are trying to think about how to address environmental problems and come up with solutions. So from the perspective of like the general public, a lot of the research that we do at the IISD Experimental Lakes area, as well as the focus of our research on the Great Lakes, is really targeted at trying to understand well, at ELA, let's say, how particular pollutants affect whole ecosystems or at the ecosystem level. Oftentimes you can't make predictions about how, acidification of a lake or adding nutrients to a lake is going to affect things at the ecosystem level when you're only doing lab experiments. That doesn't scale up very well. And we've been able to show that time and time again. And so a lot of the research that we do there, as well as on the Great Lakes, is focused on trying to come up with the understanding that we gain, being able to pass that information along to policymakers within different levels of government, be that through provincial or federal governments, to the policymakers who are forming environmental legislation to help us decide what should be the safe levels of whatever you're allowed to put into the water column if it's nanosilver, or which is sort of an antimicrobial that's in everything these days. How should we be shaping fisheries policy, whether it's commercial fisheries quotas or fishing regulations on the landscape for recreational fisheries in the face of climate change and invasive species? So we really try to make sure that we're answering questions that are going to be relevant to issues that affect the public at large.
So, Mike, your research exemplifies Lakehead University's commitment to advancing the United Nations Sustainable Development Goals. And I would certainly see including the areas of clean water, sustainable cities and communities, responsible consumption and production, climate action, and life below water. How does your work commit to these SDGs?
Yeah, it's a good question. So the life below water is sort of a bit of a given, as most of the stuff that I do is focused on aquatic research. There's a quote by a fisheries scientist from the UK named John Shepherd. He says, managing fisheries is hard. It's like managing a forest where the trees are invisible and keep moving around, right? So this is one of the challenges that we face in aquatic ecology, and why a lot of the work that we're doing with acoustic technology, whether it's through acoustic telemetry or hydroacoustics is really helping us gain a lot of understanding of where fish actually are in the water column, what their movement patterns are. That all goes towards better management by understanding where the fish are at different times of the season, and how that relates to various sort of regulations that we have around fisheries and that sort of stuff. And climate change as well. Like we've got, I would say, at least 2 or 3 of the previous theses that have come out of my lab have been looking at using the long-term data record that we've got at the experimental lakes area and trying to use that to understand how that's shaping changes in sort of the demographics of fish populations in terms of abundance and age structure, how that's affecting timing of spawning in certain species, whether that's white sucker or lake trout, and just helping us hopefully make some projections into the future as to, with kind of climate change progressing at the pace that it is, how might we expect that to affect these populations of fishes into the future, and does that require us to rethink sort of regulations around harvest?
You mentioned briefly there about data and how, with your facility and the research that's done there, how there must be just massive amounts of data over a long period of time, and how this must really help in terms of, making sound research predictions and policy.
It's pretty rare. You don't often have. There's very few places in the world that have a data record that's on the scale of what we've got. So about 50 years worth of data for some lakes. That's data at all different trophic levels, everything from algae to zooplankton to fish, as well as coming from a series of lakes, either ones that have undergone experimental manipulations, but also a set of 5 lakes that have never had anything done to them at all. So these are lakes that are just on the landscape that we use as reference lakes. So these are ones that when we conduct an experiment, we can see if there's been similar changes or not in these reference lakes to try and understand what the impact of the manipulation was. The other thing that these reference lakes are really good for is tracking broad-scale regional change, things like climate or changes in shifts in precipitation. That often reflects in the biological communities and the community structure that we see in these systems as well.
Oh, that's great. Your research seems very local in some sense, or certainly northwestern Ontario, but I bet you there must be a global reach to it as well.
Yeah, I think so. I mean, I just got off a sabbatical where I did research both in Italy and in Mexico, and looking at sort of building some relationships across the pond towards Europe as well as down south, and taking some of the insights that we've been gaining in our research here to places abroad as well. So yeah,
I think that's one of the things people don't quite realize is just how much research is an international endeavor, and the sharing of information and data is really helping at the world scale as well.
Well, sure. And it's not like pollution, whether it's microplastics or acidification or nutrients or antimicrobials. It's not like that's a isolated regional impact, right? It's not like we're the only people in northwestern Ontario experiencing that. This is a global impact. So, and we've been able to demonstrate that the experiments that we've conducted at the ELA can scale to larger systems, both the Great Lakes as well as lakes in Africa, for instance. So, so the problems that we're addressing are global in scale, but the experiments are conducted regionally just out of convenience and the fact that we can do it. So, yeah.
Okay, we're going to take another break here, and we'll be back soon. Welcome back, everyone. So, Mike, could you please share some of the knowledge mobilization and outreach activities that are part of your research?
Sure. So one of the aspects of our research, particularly at the experimental lakes area, that we didn't have when we were conducting research there under the federal government is, ironically, we have a better connection to turning the science that we do into advice for policymakers. So the International Institute for Sustainable Development was actually founded in the 1980s by a conservative government, the Mulroney government, to find ways to better inform environmental policy. And so now that we are sort of the active research wing under that institution, they're very good at helping translate the information that's gained from our experiments, turning it into advice for policymakers at different levels of government, and potentially turning that into environmental change, which seems ironic because you think that we'd be really good at doing that within government in the first place, but for whatever reason that wasn't the experience that we had previously. And then I think so that's sort of outreach at the level of informing government, but also we do a lot of outreach in terms of we've actually got an education component out at the ELA now, so we have school groups come out every year. This all, of course, slowed down over COVID, but that's starting up again now. Various groups that would come out for a tour to see the place and see what we're up to. And then, I'm also involved at Lakehead in a program called the Let's Talk Science Outreach Program, which is largely led by graduate students. Several of my students in my lab have participated, and that's really aimed at science outreach in the broader community, but particularly at sort of the junior high and high school level, to try and get people engaged in sort of scientific discovery and understanding that it's something that we're doing every day. People are doing. We're not just all eggheads and lab coats. There's a diversity of people doing research and a diversity of topics that one can look at too. So
It must happen when some of those students come out to the experimental lakes area that you see that spark in the students that you got. Like, wow, this is so cool. I want to know more.
Yeah. I would say in all the activities that I've done, I mean, it's interesting. The one thing that always kind of got me excited about stuff, which was aquatic insects and invertebrates, I often find that has the biggest wow factor with kids when we have them out too. Just because, I mean, I don't think people necessarily appreciate like how much stuff is crawling around in the water if you know where to look. And just by being able to put a name to some of this stuff and be like, oh yeah, that's a dragonfly larvae, and people know what a dragonfly looks like flying around, but they might not be able to immediately recognize what they look like in their larval stage. So and also too, just getting people interested about the kinds of questions that you can ask when you're in an aquatic environment, and the importance of those questions.
So I've learned a little bit about your emergence into the field, your current research project. What about some of your future projects?
That's a good question. So one of the things that we're actively trying to get some funding for is some ship time to get us out to a spot on Lake Superior called Superior Shoals. It's about 11 kilometers away from any land at all, so you really are in the middle of the lake. You can't see anything around you, but it's a shoal in the lake where everything around it is about 200 meters depth, and it comes up to about 10 meters depth on the shoal. And it supports this crazy abundance and diversity of fish out there, and we don't really understand why. And these little islands of high production can also act to help as a meta population to help feed different populations that are closer to shore, which are exploited, whether for commercial fisheries or for recreational fisheries. And there's some evidence to suggest that in the past these have functioned in that role. So we'd like to try and get out there to try and understand what are the mechanisms that drive this high productivity in these isolated systems, and the degree to which they are actually contributing to as a rescue population for other populations that might be more depleted. The other piece of research that we're actively investigating right now is at the experimental lakes area, doing a whole lake addition of microplastics to a lake to try and understand at concentrations that you would observe in nature currently that has not had microplastics in it before, how is that affecting the fate of those microplastics? Like, where does that microplastic go? And also trying to understand what the broader ecological implications of that are that we might not currently understand, because it's kind of everywhere already in some senses. So, yeah.
Wow. We've gone through a period with COVID where, science has really, I guess, it shaped a lot of people's future in some sense, where it's going to go. And we often hear, listen to the science, listen to the science. And listening to you today and knowing about ISD, do you feel that science is making an impact? People are actually following the policies and saying, the kind of research you're doing, the kind of research out there is what people need to hear and want to be informed about?
Yeah, I think so. I mean, ultimately, policy decisions are made at the level of a government, which is taking into account not just the scientific research, but also societal impacts and various other things. So I think the best recent example of impacts of our research is the research that we did on mercury deposition and impacts on fish consumption actually led to the implementation of scrubbers going in on stacks for coal-fired power plants across the United States and Canada. However, as a good example of how governments shape that policy, a lot of those clean air regulations were overturned by the Trump administration in the U.S. And things are slow to move back when you have changes like that. So, do they have an impact? Yes. However, ultimately, it's up to the people in charge to decide what they want to do with that information and how they balance the information on the science against the potential benefit or harm to society as a whole.
Well, I think all we can do is just present the good science and to make sure that it's there, especially in areas such as climate change and ecological restoration.
That's right.
It's absolutely essential. Yeah. Well, thank you everyone for tuning in to another episode of Research Matters. Today, one of Lakehead University's Canada Research Chairs and leading researchers, Dr. Michael Rennie, shared his understanding of how our ecosystem functions and how this information can help foster productive and sustainable ecosystems. So thank you for sharing with us today, Mike. It was fascinating.
Thanks a lot.
And I look forward to introducing you to another one of Lakehead University's star researchers in our next episode. Again, my name is Andrew Dean, Vice President of Research and Innovation at Lakehead University, wishing you the very best.